Next up, we have a session, really another practical one when it comes to managing BigQuery at scale. We've talked a little bit about, backup, protecting your BigQuery data sets, et cetera. There's a lot of capabilities that are being added to BigQuery. A lot of more use cases, are being implemented and used there. So we have Orion Omer is joining us actually from Eon. And he's going to be discussing the rollback playbook for BigQuery. So he's going to be getting into what are the capabilities, both native and third party, that are available there for making sure that we don't get caught with corrupted data or misconfigurations, etc. So Orion's going to be live in the chat, and he's going to be joining us for the Q&A as well after the session. But before we jump into the session, let's do a quick poll. So for everybody here that's using BigQuery, what is your backup strategy? So what are you doing for backups today with BigQuery? We're going to launch that poll. And then once we actually get and see that, I know that we have a lot of different types of people here, whether you're using like a custom export, you're depending on time travel, or if you have some type of third-party solution or doing snapshots. Lots of different. It looks like we saw, and I think we know most people are depending on the time travel capability, the 7-day window that exists within BigQuery. And second place, usually what we see is people leveraging snapshots on the table that are available from BigQuery. So what we can do is we'll end this poll and we'll take a look. So thank you for going, and you can take a look at the results there. Just like we saw, most are leveraging time travel, some table snapshots. And of course, there are those that are doing custom export to GCS or another tool. If you're one of those that are doing the custom export, feel free to share with us in the chat what it is that you're actually doing. And with that, we're going to pass it to Orion for his session on the rollback playbook.
Hey everyone, I'm really excited to be part of this event, and I want to start with something simple. Today, data is no longer just analytics. Your data is your business. It's the semantic layer your organization operates on top of. It's the shared context that connects the customers, the product, transactions, policies, workflows, and the operational logic across the company. And increasingly, the data is no longer consumed by only humans. It's feeding AI system, AI agent, automations, and dashboards. In many organizations, agents are already taking actions based on their data, approving transactions, routing workflow, making operational decisions in real time. So the data warehouse is no longer just a reporting system. It's becoming the operational memory and reasoning layer for the business. Now, think about it for a second. What happens if that foundation is wrong? Not down, not unavailable, just wrong. A corrupted dataset, a bad schema change, duplicated transactions, or just a missing context. And nobody noticed immediately. Because that's the scenario that we are going to focus on today. No infrastructure outage, no catastrophic failure, silent data failures. The kind where the system still runs, the dashboard still loads, the agents still execute actions, but the decision being on top of them slowly becoming correct. And this is dangerous in the age of AI agents, because agents do not just read data, they act on it. If the semantic layer becomes corrupted, the agent uses that corruption as true. And BigQuery is like extremely reliable infrastructure, but reliability does not automatically mean that you can recover. And that's really the gap that Stock is about. What actually breaks in a real production system, why teams usually discover it too late, and what recovery looks like when the data foundation, your business and AI system depend on becomes wrong, corrupted, or unavailable. So I'm Orion Omer, I'm a software engineer at Eon, and I've spent the last 10 years building and scaling data system across cloud security, AI, and distributed system. I work across the IDF, Superwise, Salesforce, and Palo Alto networks, and now at Eon. But the common thread across all of that is seeing what happens when data breaks at scale. and how hard it is to recover when you are not ready for it. Outside of work, I tend to enjoy things that involve a bit of risk and endurance. I'm a wave surfer, snowboarder, marathon runner, and a skipper. So let me walk you through what we are going to cover today. We will start with what actually breaks and why teams almost always discover it too late. Then we will zoom at what BigQuery gives us today and where those capabilities are actually very strong. From there, we will zoom into the gap, the moment where rollback isn't enough and teams realize that they are not fully protected. Then I will walk you through a practical playbook, what to actually do when something goes wrong. And finally, how to make all of this real in production, not just something that looks good on a slide. By the end of this session, you should have a clear way to think about recovery, not just tools, but decision. And of course, we have a Q&A at the end. So BigQuery today is not just an analytical engine anymore. For a lot of companies, it becomes the system of records for critical business operations. It's the semantic layer the organization operates on top of, the place where business context, operational data, customer activity, financial system, and AI pipelines all connects together. And increasingly, companies are building agentic systems of top of their data foundations, AI agents, copilot, automation, and etc. Which means your data is no longer just powering dashboards. It's actively driving actions and decisions across the company. Think about it, financial reporting, month-end revenue numbers, focus in dashboard, board-level KPIs, the numbers executives are making decisions on. Think about operational system, inventory, customer activity, supply chain data. The system the business depend on every single day. And increasingly, AI and machine learning pipelines where your model, agent, and automation system are only good as the data that's feeding them. If the underlying data becomes wrong, everything that built on top of it becomes wrong too. A dashboard that starts drifting, a forecast that becomes inaccurate, an AI agent that making the wrong decision, or an ML model that starts generating bad predictions in production. And the dangerous part is none of this usually fails loudly. Nothing crashes, no alerts goes off, the pipeline stays green, the system looks healthy, but the underneath, the data is already corrupted. And once your semantic layer becomes wrong, everything that's consuming that context starts drifting with it. So when something breaks, the blast radius becomes huge. It's not just a table anymore. It's your CFO that's looking at the wrong numbers. It's the dashboard that's driving bad decisions across multiple teams. Its customer-facing analytics become unreliable. Or is an AI agent that's making incorrect decision because the context they relay on becomes wrong. And the hardest part of it, most of the time, you don't even notice this immediately. Sometimes the issues sit there for days, sometimes even weeks, until someone say, oh, this number looks a little bit weird for me. And by then, the big data already spread everyone there downstream into dashboard, reports, machine learning pipelines, agentic system, and etc. So data is your business until it breaks. And here's the part that people do not like to talk about. This is normal. No edge cases, no rare incident. This is what real production environments looks like. And usually it's not that dramatic. It's just a small mistake with a very large consequences. It's an engineer that ran a delete with the wrong workloads. Is a pipeline that deployment quietly duplicates transactions? Is a schema change that shifts a join key and corrupts downstream analytics? Or is just a new dataset that gets created during a launch and never gets added to any backup policy? So nothing crashed, the dashboard still load, the pipeline still green, the query still run, but the underneath, the data is already wrong. And that's what makes this failure so dangerous. Most teams discover them too late. Maybe revenue suddenly looks off by 2%. Maybe an AI agent starts making incorrect decisions because the underlying context slightly drifted. Maybe finance discover missing data at the end of the quarter. And by then, you are not debugging anymore. You are managing an incident. We even saw a public example of this recently. A company called Pocket OS, which provides operational software for car rental businesses, had its production database and backups deleted by AI coding agent that running to cursor with a cloud model underneath. So the infrastructure itself never failed. The system stayed online. But within seconds, reservation, customer records, and operation data were gone. Rental businesses show up the next morning and unable to access the system they depend on to run their everyday operations. So recovery took days using an old offsite backup and manual reconstruction from some external system. And that's exactly the kind of failure that this talk is about. No infrastructure availability, but more about recoverability. So now to be clear, BigQuery actually gives you very strong built-in protection. This is not where things go wrong. In fact, from an infrastructure perspective, it's extremely solid. We have time travel, which lets you to rewind a table to a recent point in time as long as you are still in the time travel window, where you have snapshots, point-of-time copies of your tables. If they were created and maintained, you can roll back to any point in time. You have the built-in durability of BigQuery, so your data is highly available and protected against infrastructure failures. And of course, that you have the IAM, which control who can access or modify your data, which helps you to prevent accidental or unauthorized changes on your data. So these tools are excellent tools, and in many cases, they're like exactly what you need. But if you catch the issue fast, if a table gets deleted and you notice within hours, so you are fine because you are still in the time travel window, so you can rewind the table, restore it, and move on with minimal impact. If a pipeline breaks and you catch it in the same time, so you are fine because the bad data hasn't spread too far yet, so you can fix the pipeline and roll back the small window of data and recover quickly. But if you don't catch it quickly, so the same delete is no longer recoverable. The same pipeline has now overwritten days of good data, and suddenly recovery is no longer simple. So all of these capabilities are built around one underlying assumption, so that you detect the problem quickly. And as we saw earlier, that's not how most failures actually happen, because in reality, issues aren't discovered in hours. They are discovered days later, sometimes weeks later. And by the time that you realize that something is wrong, you're already outside the safety window, outside the time travel window, outside the easy recovery. And that's the gap. This is where team gets surprised. Time travel is limited up to 7 days. There is no longer retention strategy. There is no cost region backup, no centralized visibility into what's actually protected. And this is the moment that you realize that you're not just missing a tool, that you're not actually protected. So what does good looks like? Not tools, but outcomes. Good means that at any moment you can answer 3 simple questions. What's protected? How long it's retained? And how fast you can get it back? And if you can't answer those, you don't really have a recovery strategy. You have just tools. Now, getting there isn't a magic. It comes down to a few core capabilities. You need to have a long-term retention, so you're not limited just to a few days. You need to have an incremental backup, so you can scale without exploding your cost. You need to have some cost region resilience, so you're not exposed to a single failure domain. And of course, you need to have some granular restore, so you can recover exactly what you need without taking everything down. And this is the shift. Modern data protection is not just about snapshots. It's knowing that no matter what happens, you can recover anytime with confidence. So let's make it this practical, because when something goes wrong in production, you don't want people improvising under pressure. You don't want engineering guessing. You don't want teams arguing about what changed, and you definitely don't want that someone will run some random script directly on your production data. Because by that point, the blast radius is already expanding. Dashboards are wrong, reports are drifting, AI agents are making incorrect decision based on that corrupted context. What you want instead is a clear, repeatable recovery process. a playbook. So the first step is detecting the issue. And honestly, that's usually the hardest part because most failures do not announce themselves. They show up as weird numbers, drifting dashboards, failed reports, agents that start behaving unexpectedly. Once you know that something is wrong, so the next step is identify the right recovery point. What was the last known good state of your data? Before the corruption spread down, before the clean data got overwritten, then you choose the recovery method. Can you use time travel? Do you need snapshot? Do you need to restore from backups? Can you recover just a table or even only a specific record without impacting everything else? So then come the actual restore. And this is where things get risky because recovery itself can create more damage if you rush it. A bad restore can override good data, retrigger pipelines, break dependency, and etc. So after restoring, you need to validate everything carefully. You need to verify that the data is correct, that the pipeline are healthy again, that the dashboard reconcile, and your AI agents are operating on trusted context again. And finally, you need to capture evidence. What's happened, when it started, what changed, how recovery worked, what gaps were exposed. Because recovery is not about fixing the data, it's about understanding the failure, proving what's happened, and making sure the exact same incident does not happen again 6 months later. And that's really the mindset shift here. The goal is not just about speed, it's recovering quickly without making the decision worse. So now in practice, this comes down to a few clear paths. If you are within the time travel window, so rollback immediately, that's your fastest and simplest options. If you are outside of that window, you move the snapshots or backups. That's where your long-term protection matters. And in some cases, you don't want to restore everything at once, so you want to restore incrementally the tables or even just specific records to reduce the blast radius. So the decision isn't just what works, it's what works, it's what gets you back to a correct state as quickly and safely as possible. So how do you make recovery work consistently? Not once, not during a perfect demo, but every single time production breaks. So you need what I call it a data shield. Because recovery is not just a feature, it's not just a backup job, and it's definitely not just a checkbox for compliance. Recovery is an operational system, and strong recovery systems usually have 3 layers. The first one is governance. You decide what actually needs protection, how long it should be retained, what recovery objectives matters, and most importantly, who owns it. Because one of the biggest causes of backup gaps is simple. Nobody thought they were responsible for that data set. So the second layer is execution. This is where protection becomes automated. Backup run consistently. Coverage gets monitored. New datasets do not silently appear unprotected. And this matters more than people think, because at scale, manual processes always drift over time. And the last one is assurance, because the existence of backups does not mean that your recovery works. You have to test restores regularly. You have to validate the recovery path. You have to know how long recovery actually takes under pressure, because the worst time to discover a recovery process is broken is during an incident. And it's really the shift, the difference between hoping that you can recover and actually knowing that you can. So how do teams actually build this in practice? So the reality, there isn't a single perfect solution. What teams are really doing is combining multiple protection layers, and every layer comes with trade-off. So snapshots are usually the first thing teams use. They are fast, simple, and great for point-in-time recovery. If someone deletes a table and you catch it quickly, snapshot can save you very fast, but snapshots still live in region. So if you're thinking about regional failure, disaster recovery, or a true isolation, snapshots alone are not enough. And operationally, they also tend to drift, because some of them are manual, some datasets get covered and some don't, And over time, coverage gaps become very common while using snapshots. Then we have exports. Exports create an independent copy of the data, usually into GCS. That's much stronger from a retention and an isolation perspective from snapshot. And now you have something that live outside the system. But we need but it's important to mention that exports are heavy. They consume resources, they take time to run, and at scale, they become expensive very quickly, especially when you are exporting large datasets repeatedly. And the operational side as well get complicated as well. Managing export consistently across hundreds of dataset project and environment is much harder than people can expect. Then we are moving to custom pipelines. This is where teams want maximum flexibility. You can build whatever you want. You can build incremental backups, custom retention logic. You can develop a metadata aware recovery, cross-region workflow, and etc. But basically, you can do whatever you want. But now you own the entire system, scheduling it, monitoring it, retries, recovery orchestration, and failure handling. And eventually, your backup system become another production system that you need to maintain. And that's usually where operation complexity start exploding. And finally, you have the managed solution, okay? This treat backup and recovery as a complete operational system. Protection gets automated, retention gets managed consistently, coverage becomes visible, and honestly, visibility becomes one of the biggest advantage. Because most teams actually do not know exactly what's protected until something breaks. And that's really the key point here. No single approach solves everything. Snapshots alone are not enough. Exports alone become hard to scale operationally. Pipelines alone become difficult to maintain reliability. So it's important to understand that strong recovery systems are built in layers that balancing the speed, the cost, the operational complexity, and of course the reliability. So now the real question becomes, how do you actually operationalize all of this in production? So up until now, we've been talking about concepts, strategies, and recovery patterns. But when you are running real system at scale, you need to have a concrete operational capabilities behind them. At a minimum, there are a few things that you absolutely need. You need to have a long-term retentions because real incidents are often discovered far outside of the 7 days time travel window. You need to have a cross-region resilience because infrastructure failures, outage, and regional incidents do happen. You need to have a granular restore because nobody wants to restore the entire environment just to recover a single table or few bad records. And of course that you need visibility because you can protect what you actually don't see. You need to know what's protected, what isn't, which policies are applied, and where your gaps are before the incidents appear. And this is the shift from having backup tools to having some operational recovery system. Let me show you what it looks like in practice. So this is where Eon fits into the picture. Eon provides those capabilities out of the box, the long-term retention, the cross-region resilience, the granular recovery down to tables or even records, the immutable backup, and the centralized visibility across all of your environments. But instead of keeping this theoretical, let me walk you through the actual workflow. So the first thing that you can get after you are doing the onboarding to Eon is the inventory visibility. And honestly, this becomes incredibly important at scale because most organizations do not actually have a clear answer to a very simple question: what data is protected right now? With the inventory view, you can see immediately all of your resources, whether they are protected or not, which policies are applied, where backup exists, and where coverage gaps exist. Eon also runs data classification on your data so you can identify which BigQuery dataset contains personal information or financial information. As well, Eon performs some environment classification to understand whether the resource belongs to a production or a non-production environment. So if you are going to drill to a specific resource, we can see much more details about the BigQuery dataset itself. We can see the dataset properties, the sizes, the time travel windows, the amount of the metadata about the tables, amount of material views, and etc. Then, if we are going to move to the backup policy, we can see why this resource is protected. We can see, for example, that this resource is protected because it contains some personal information or financial information, and it's labeled as one of the production resource. We can also see the retention configuration, the backup region, the recovery setting, and the overall protection strategy that associated with that resource. From there, we can move to the snapshot history and see all the recovery points for this dataset. And from there, recovery becomes very straightforward. I can choose a point in time, a snapshot, and from there, I can choose whether I want to restore the whole data set and the location that I want to restore. I can choose to restore specific tables, or even we can use the Eon Database Explorer and even run a specific records restoration. So this is important because one of the most capabilities here is to run restore drills. Because the existence of backups does not automatically mean that the recovery works. You need to validate recovery regularly. You need to know that the process works under pressure. You need to know how long recovery actually takes. And that's the difference between having a backup strategy that's written in some documentation and having a recovery process that you can actually trust in production. So let me leave you with 3 final takeaways from this session. So the first one is BigQuery is highly durable, but that's incredibly valuable. But durability is not the same as recovery. Durability protects you from infrastructure failure. Recovery protects you from human mistake, bad deployments, corrupted pipelines, silent data drift, and late discovery. And those are completely different problems. The second one that most real failures are not discovered immediately. In production environments, bad data often sits quietly in the system for days, sometimes even weeks, before anyone notices that something is wrong. And the longer corrupted data live in production, the hardest the recovery becomes. Because by the point that the damage is already spread down into dashboards, reports, AI agent, and etc., at that stage, recovery is no longer simple. And the last one, and most importantly, backups alone do not create confidence. Restore drills do. Because by the end of the day, nobody cares that the backup exists. They care that the recovery actually works when production is under pressure. They care that the restore process has been tested, that the recovery points are valid, that the team know exactly what to do during an incident. And honestly, the real test of your recovery strategy is very simple. Can you recover quickly when nobody saw the failure coming? Because that's how most real incidents actually happen today. So thank you so much. And now, of course, I will be happy to have your questions.
Wow, Orion, thank you so much for that session. I think, after everything that we've seen today, looking at all these different new features in BigQuery, different ways teams can implement, scale, optimize, everything like that, really, really important to also think about actually protecting this critical data that exists there. So let's talk. I know there were a couple of questions that you were answering in the chat, and all day we've actually been getting questions about protecting data, snapshots, time travel, etc. So one thing that I think is interesting, you were talking about time travel, 7 days of data that you can kind of roll back to if you need to. Based on our poll, right, most teams seem to be relying on that. Can you give us a scenario of like a BigQuery user where they would run into finding out that time travel isn't enough?
Yes, so of course, one of the most common scenarios is like delayed data corruption or just an accidental deletions. Like by the time that the issue is discovered, the time travel retention may be already passed, which makes the recovery impossible. Another important limitation about time travel that it lives in the same environment and in region. So it's depend on the same project, permission, and storage there. And it does not provide you like a true isolation or some immutable backup that guarantee. So that's usually like the point where organization realize that they need a real backup architecture with long-term retention, some isolated storage, and point-in-time recovery.
Okay, so basically saying, if your backup or the data that you're planning to roll back from lives in the same blast radius as all the primary data, you might get caught stuck without data to recover in some case. And I think
Exactly.
a big part with what you're talking about here is, and we saw it today, like starting from the keynote and all the way through, that we have all these different AI, capabilities both within BigQuery and AI systems that can now talk to BigQuery as a data source. How does it change the need for backup? Does it actually impact any need for protecting data in BigQuery data source?
So so we can tackle it from so many places, but AI workloads create a new challenge for backup. We can see it from the rate of change of the data that become much higher. Agentic system like constantly update data where is like the memory, the intermediate data set, features, so and so on. So traditional full backups are almost unrealistic today. Then we can move to the challenge where organization increasingly need the ability to reconstruct the exact context for AI for a specific point in time. So it could be the prompt, the retrieve context, the embedding, the tools, and the model responses. So you don't need to restore only tables. You need to create a point in time for multiple layers of your data.
Okay. No, it's a really great point, and I didn't think about that. Thinking from the perspective of the data that's also getting created by AI, not just the different AI workflows on top of BQ. And then last question, we actually have one from Sean, who's asking, do we have to consider for protection other aspects? So like BigQuery functions, views, save SQL, scheduled SQL, etc.
So of course you should have a full protection layer for all of your metadata. It could be your views, your materials used, scheduled queries, self query, and etc. Routines and everything, because you want to create a point in time a point in time recovery points for all of your BigQuery environment that you will able to recover from.
Okay, no, that's a good point. And I think if there's anything that we saw from today, it's not just the data. People that are using BigQuery, they also need everything else. And actually, just I think Jesus also asked this question: does Eon back up information schema data, queries, etc.? And I think that's what you're saying, Orion. Like Eon as a
Yeah,
product takes into account the other stuff, not just the data.
we are taking everything in count. That's
Mhm.
correct.
Okay. Well, really, really appreciate it. And like we've been moving from session to session. So this was a really, really great look into why we should evaluate how we're actually protecting our data that's in BigQuery. So thank you so much, Orion. And now we're going to move into our final closing session.